Okay, so I'm going to talk about the close principle written just there. And here is a slide about me. But basically, I'm a freelancer, which is probably not interesting for everyone. But if you hire freelancers, just get in touch. And this means I'm seeing quite a lot of very bad code most of the days. Uh, that's what we do. I'm also CEO in a company, a small company, services company again. So as it's services, obviously it's not great either. And the interesting part is the part you can't see, which is down there. I'm organizing 2 conferences, co-organizing, to be fair. Uh, one is in Scotland. Sorry about that. Oh, here we go. So one is in Scotland because I used to live there, and one is in Brazil because a friend of mine used to live there. That's why. If you want to come, this one is in a few weeks, so that might be tricky. But this one's way far away, so you can definitely come. Today's talk is about one of the solid principles. I hope most of you know solid principles. If you don't, just go and have a look. That's really cool. It's a list of different principles, as it says. It basically allows you to write better object-oriented code. And so if you don't know them, go and look them up. I'm going to talk about the open-close principle. You can't really use them separately. We will have some references to the SRP principle, which is the first one, the single responsibility, because it makes sense with what we are looking here, and a bit of references on dependency inversion as well. That's the definition of the open-close principle, basically. Open for extension, close for modification. I'm pretty much done, obviously. That's what it means. So open is you need to let people work on top of your work, basically. You need to let people add features, add whatever the business requires, basically, for it to work. But because you're a developer, you don't want people to touch your code. What you've done before, it's done. Because of SRP, because of some other stuff, some other principle, you're supposed to have done the whole feature. So if the whole feature is done before, that's done, that shouldn't change. If you change it, you probably are going to introduce bugs, probably going to have side effects of some sort. Don't change stuff. That's what we're looking at. If you look at where you've seen this principle in the wild, probably when you use vendors, if you use packages, if you team at work, and you of this kind of use case, you'll see that the first one is if you want to change the code of an open library and you've got a good use case for that, people will be nice and let you change stuff if it's not specifics to your project. But if you have a core team, most of the times there are problem of egos and this won't never change. So that's what you have, and because of this in your own code, but you can't change anything, basically. You need to work around of this, and how can you do that? So the first approach, which some people won't like in the room, I see some kind of is basically extends. If you look at the definition again, you'll see that it extends something. Extends, not like this extends. So the first approach was I'll inherit something and I'll just override anything that doesn't suit me. So I've got this class called data provider, very bad name, just for the example, and it basically provides data. That's what it does. And your business logic is, for some reason, GDPR, whatever, you need to add a logger to this. So some people will just add the logger as a dependency and that's it, and yeah, don't do that. Something else, because we work with closed classes, so we won't change all of this code for this example. So how do we add a logger? We've got a logger, obviously, and we just create another class that extends the first class we had. This works, definitely, no problem. Okay, so what's the problem then? If this works, why won't I use that? If we want to add some layer of caching, for instance, on top of what we already have, what's going on? So I've got two paths here. One is my data provider, then my cache, then my log cache. The other way is going log first and cache then. Okay, right. What if I add another layer? I don't know what, but another one. My tree will just grow, and then my dependencies will look like shit. That's what my dependencies look like, and here I've got already two dependencies to two services, which have nothing actually linked in, so it's not really great. So how do we deal with that? We'll switch from inheritance to composition. It's as basic as that. And that's the more recent approach, recent like in 1996. So it's not that recent. Most of the software engineering strategies, methodologies have been developed way back. We just need to learn them back again and again and implement them properly. So how do we switch from one to another? We've got plenty of design patterns that suits this use case, this specific use case of extending. Extending is letting people do stuff on top of what you already have. So decorator, if you don't know about decorator, I'll speak about it just after. Observer is another one. You can do other stuff. I'll also speak about it, that's why it's in blue. And then the black ones, we won't have time to cover them, but that's other design patterns you can have a look at. There's a very great website, I think it's designpattern.guru or something like that, refactoring.guru. You can go and look them up. It's very well explained. So yeah. The decorator pattern is probably my favorite for this very specific use case. I find but very well. So instead of the word we had before of inheritance, just split components, but still our data provider, the base class we had. Now we've got a cache data provider, a log data provider, which are using the same interface. If we want it this way, is the data provider, then the logger, and then the cache, or the other way around, up, with the logger down there, and the cache in the middle. Because we're composing, it just depends on what order we use when we instantiate it. So, in terms of code, my code doesn't render just like I wanted, but that's fine. And then the logger, obviously we've got some cache, and we've object we composed from the previous object we had. Now instead of inheriting, we're composing, so we're injecting here the object we want. The provider in this case is the data provider, or it might be the log data provider, or some other cache data provider, or whatever you want. In fact, as long as it supports the same methods. We used to have a parent call. We just link to the dependency. we can have any code we want above or down. That we can execute code for after as we want. So now we've got this, which changes the behavior of my whole component in my system without changing the code of the existing class. That's the same one, exact same one with the cache. The logic over there changes a bit, but that's the exact same dependency principle. We had one problem with that here. That's if you type your code, which I encourage you to do, you can see here I haven't got a type int here yet. The problem with not having a type int is I'm not sure whether in here I'm able to use the provide data method. So how can I be sure I can use it? The first approach would be typing provider over there, data provider, which is my class. That's fine, but that decorator pattern, the decorator pattern says it has to be an abstraction of some sort. So we're going to introduce an interface data provider and then change as data provider we add to whatever name you want. My provider just provides from memory, so in-memory data provider is fine. I'm able in here say that's a data provider, and that just anything I have under that will be a data provider. The data provider is a data provider. The data provider is the same. That's how we can instantiate it. So it doesn't look really great. We're trying to make better code, and we now have all of this instantiation. Don't copy paste this everywhere, and don't use traits to have that pretty much anywhere as well. Is use a dependency injection container. So now, when we want the data provider, whatever this means, in-memory data provider could be the cache data provider with the in-memory in it. Who's using Laravel? Okay, a few people. People don't want to say they use Laravel, but a lot of people use it. I mean, that's fine. You can say you use it. It's good. So that's how you would do something in Laravel. And it's pretty easy to do, actually, to implement. That's the config of your container, which is exactly the same as the Symfony container over there. I'll just jump to Symfony just after. So whatever your framework is, that's basic software engineering. So every framework supports it, I guess, or at least. If your framework doesn't support it, just go to another framework which supports it. Here, this extend keyword. Extend, in this case, is basically use a decorator in Laravel. So, the link of the code if you want after the talk somewhere. I don't know where yet. So you create a data provider because Laravel needs to have kind of data services into the container. And that's where you're going to put all of the binding we've seen before. Same thing, I'm using YAML because I know there are a few YAML fans in the room. So using YAML here and just say, okay, we've got this data provider here, which is my interface. We've got the memory data provider, which is the actual class we had at first. Again, the log data provider will just decorate the service, and this one will decorate this service as well, which will be this one at this time. So it's just cascading, basically. So that's great, but how do you know what's ordering stuff? You can deal with ordering stuff using the decorator priority, which means the priority is executed first, so it's inside of it. Just what order you want. Say you want to send an email and log and maybe, I don't know, your log for some reason don't work, you might want to have the email first and the log then, or if it's in some sort, you may want in another order. That's quite interesting. That's how you basically deal with which order you want here. Right, so as one approach, decorators, which does work well, but is not used very often. Another approach would be use an observer. Everyone knows the observer pattern, approximately. We won't use it directly. Most of the libraries you have out there don't use the observer directly, but use the mediator observer pattern. That's what we have in most frameworks. So that's a basic observer. And the idea is, on this class here, the publisher will have subscribers, and then we will be able to notify subscribers. Any subscriber here, so by subscriber we usually refer to what you call listeners, or even subscribers, or whatever is the terminology in your preferred framework. But and everyone who are guys here will just do what they have to do. In your case, the first class we had, we'll change it a bit and use it as, in our case, as the client or as the publisher. That's what the in kind of, so you're plugging in other bits of code at specific times in dispatch, basically. That really helps with reusability, because the first approach we had, decorator, you need to create your piece of code for every bit you want to override or decorate in the case. But basically, because you have to follow the very same interface as the service you're targeting, you're kind of stuck with that. You need to say you have, I don't know, some kind of data provider somewhere and some kind of data consumer elsewhere. Different interfaces, so you will need a decorator for each. If you're using your decorator and might have the same kind of events, so maybe you'll be able to reuse the same. That's one of the advantages. Right. So in Laravel, again, that's an event, that's a class, plain object, and you just pass in whatever you want, and that's it, it stores it. Then in your handler, which here is my app listener, I'll just buy my event, dump it. And in here, I'm just saying for every demo, so the previous event that is raised, I'll just listen with my client. And here is the way to trigger all of that. So whenever this is it, we're sending a demo event, and that's and this bit over there is executed. That's not very complex. To be fair, this is something people actually use in projects quite a lot. So the same thing is available in Symfony. So we kind of have the exact same event. Symfony requires to extend events for some reason, but that's the same class. And then again, just change the namespace, but that's it. And my config in YAML here is the equivalent of the config in PHP in Laravel. It basically says whenever the main event listener dispatches event demo, it basically with this service. So that's actually pretty easy to use. You just inject your event dispatcher over there. Event dispatcher interface in Symfony just gives you the main event dispatcher. And then you're just left with dispatching your event. That's it. So this way, anyone that uses your library or bit of code, whatever you call it, but this class you've done first, is able to fetch whatever you wanted to send. So in the decorator strategy we had before, the decorator just receives whatever you use is sending back. In here, you can add more information if you want. You can basically pass anything you want in this demo class here, which is my event class. So you can have some more text, whatever you need at this point here. So it's a slightly different approach. And that's done with Symfony. That was the same as Laravel, basically. So the problem we have now is code to whatever bit of code we use to trigger thing at first. A quite big class, which for some reason uses, I don't know, a repository, and maybe some other object calisthenics. If you don't know them, that's another set of rules, quite that two instance variable. So if you're starting to add some more things in your constructor here, that's going to be a mess. So what we're trying to do here with cleaning up is basically have one reason to change, not more. So we can dispatch decorators. You've got your base class, which used to do what it does. Don't inject the event dispatcher in it. Inject the event dispatcher in a decorator that decorates your first service. And then from here, you can send your event. And this way, you never mess with someone else's code. It's not framework related, while I've used a lot of frameworks in it, but it's proper software engineering, so don't focus on what example of. It's just to show you it's very easy with basically anything. Laravel and Symfony, this example. I could do you the Zen version of it in no time, if you want. And try to split your code as much as possible and never go and touch it back. Just work properly around it. That's me. Last talk of the day, so joined in for me and for the others. Like, comments, and Twitter is the best way to get